Today we are going to discuss test 1 plus 2 class. Topic is solid state and solutions. Now in this test, question 1 is, which of the following expressions is correct for cesium chloride unit cell with lattice parameter A? Question number 1, your option is C. How it comes to be C? In case of cesium chloride, cesium is the cation, chloride is the anion. In this structure, chloride is at corners, and cesium is at body center. If it is at corner and body center, in a cubical system, this body diagonal is going to have chloride, then again chloride at the corner, and cesium is in the middle. This is the cesium position. This body diagonal is root 3a. Body diagonal is equal to root 3a. And at this body diagonal, there are 4 radii. Radii of chloride, 2 times radius chloride plus 2 times radius of cesium, 1 positive. It is equal to root 3a. 2 can be common. We can say radius of chloride plus radius of cesium, 1 positive, is root 3a. And in your question, we are having capital R is given, R radius, cesium 1 positive plus capital R chloride. This will be equal to root 3a by 2. So your answer is root 3a by 2, C option, question number 1. Now we have second question. Question number 2 is, calculate the ionic radius of cesium ion, assuming that cell edge length for cesium chloride is 0.4123 nanometer and that of ionic radius of chloride ion is 0.181 nanometer. Now question number 2. Second question. In this question, again the structure is of cesium chloride, but now we are having cesium chloride with a given value of your edge length. A is given to you as 0.4123. Radius of chloride, it is given as 0.181 nanometer. And our question is, calculate the radius of cesium 1 positive ion. This radius we want to calculate. Options are, we have to take root 3a is equal to 2 times radius of cesium plus radius of chloride. It means root 3a by 2 minus radius of chloride will be equal to radius of cesium. Root 3 is 1.73. Edge length is given to you as 0.4123 divided by 2 minus 0.181. This will become radius of cesium, cesium 1 positive. On solving this value, we get 0.357 minus 0.181, and your option will become 0.176 nanometer. So 0.176 nanometer, option is A. Second question, the answer will become second question, option A. From this question, it should be very much clear that radius of cesium 1 positive is 0.176 nanometer, while that of chloride is 0.181 nanometer. It means anion is still bigger than that of cation, although this cation is of alkali metal cation. Cesium is present at the last, still it is smaller than Cl negative. The cation of cesium is smaller than that of chloride. Its radius comes out to be 0.1676 nanometer. Question number 3. Third question, it is about zinc sulfide structure. In this question, zinc sulfide exists in two different forms. One is zinc blende, another is woodsite. Both occurs as coordination number 4:4. Choose the correct option from among the following. Option A is zinc blende has BCC structure and woodsite has FCC. Zinc blende has FCC structure, woodsite has SCP. Zinc blende as well as woodsite have same HCP structure and both are having same CCP structure. For this question, we must know the structure of blende and woodsite. Question number 3. For question number 3, zinc blende and zinc woodsite both are having the formula same. Zinc ZnS, this is the formula. When we say it is zinc blende or its woodsite, both the structures are like. In zinc blende, we are having sulfide with CCP arrangement and alternate tetrahedral voids are occupied by zinc. Alternate tetrahedral voids are occupied by zinc. Zinc 2 positive. In case of woodsite, it is sulfide is now hexagonal close packed structure and zinc is still in the same alternate tetrahedral voids. Alternate tetrahedral voids. Now both the structures are showing same coordination number because zinc is present in tetrahedral void. Thus we can say the option correct is B beta. In this we are having third question, B option. CCP or FCC is same. Thus we can say zinc blende has an FCC structure and woodsite has HCP, hexagonal close packed structure. Question number 4. Fourth question is iron crystallized in BCC arrangement. Lattice parameter is given. Calculate density of iron in this BCC system. This question is related to density. Question number 4. We want to calculate density of your iron. Question number 4. When we say density, formula of density is Zm upon AQ, Avogadro's number. For this question, it is written BCC. BCC means Z is 2. Second point. In this question, lattice parameter A, H length is given to you as 2.861 Armstrong. When it is in Armstrong, we should say 2.861 10 raised to power minus 8 centimeters. Iron mass is given to you as 56, exact 56 is given, and Avogadro's number is given to you as 6.02 10 raised to power 23. Now putting the values of all these factors, Z is 2, M is 56, A is 2.861 whole cube into 10 raised to power minus 24, 6.02 10 raised to power 23. 24, 23 cancelled out, we are left with just minus 1 power. This value is left. Now on solving this, you are getting the value 7.92 approximate gram per ml. Your option becomes 7.92, A option. Next we are having is fifth question, fourth answer A, question number 5. Question number 5 is about potassium chloride crystallizing in the same type of lattice to that of NaCl. Given that radius of sodium to chloride is having ratio of 0.5 and sodium to potassium the ratio is 0.7, calculate the ratio of side of the unit cell for KCl to that of NaCl. Now in this question, first of all we must target the point which thing we want to calculate. Question number 5, we want to calculate ratio of the side of unit cell, that means edge length of sodium chloride unit cell and that of edge length of potassium chloride unit cell, and we want to take the ratio of these two. Edge length of KCl is 2 times radius of potassium plus radius of chloride, and ratio 2 times radius of sodium plus radius of chloride. This you want to calculate. 2 and 2 is cancelled out. It means our question is, we want to calculate radius of potassium 1 positive plus radius of chloride divided by radius of sodium 1 positive plus radius of chloride. This is our target. For this target to be achieved, we are having given information: radius of sodium 1 positive, radius of chloride is equal to 0.5. This value is given to us. For making it sodium plus chloride, let's add sodium 1 positive by chloride plus 1 is equal to 1 plus 0.5. Add 1 on both the sides. You will get radius of sodium plus radius of chloride divided by radius of chloride is equal to 1.5. This value we have achieved. Now this is our first equation. Let's keep it 1. Second part here is radius of sodium upon radius of chloride is 0.5. It means radius of sodium can be taken as 0.5 times radius of chloride. You can take this value. Now we have, if we want to have third part, radius of potassium upon radius of chloride, if this is the requirement of ours. In this requirement, we can put radius of potassium divided by radius of chloride के place पे क्या लिख सकते हैं? We can write sodium upon 0.5. Radius of sodium divided by 0.5. It means radius of chloride we have taken radius of sodium divided by 0.5 value. This is the equation. We can make this equation as 0.5 upon radius of sodium divided by radius of potassium, and this complete is given as 0.7. Sodium upon potassium is given, this is given to you as 0.7. It means now we have radius of potassium upon radius of chloride is equal to 0.5 by 0.7. Now make this equation as radius of potassium plus radius of chloride plus 1 is equal to 0.5 by 0.7 plus 1. So we are having this equation solved as 0.7 is the LCM, or we can 7 and 5 is cancelled out. 7 is the LCM. 5 plus 7, 12 by 7. Potassium upon chloride plus 1. This equation is now becoming, we are having radius of potassium plus radius of chloride upon radius of chloride is 12 by 7. These two are our second, this is now your second equation. If we want to have KCl upon NaCl, so second divided by first. Second divided by first will give you the value 12 by 7 divided by, it is, this value is 1.5. Okay, into divided by 1.5. This is the value. 12 by 7 into 1 by 1.5. On solving this, you will get the value 1.143 around. Option is 1.143. This is given as option A. Your option will become A option. This question is little bit tricky question. Let's repeat again. First of all, our target is radius of potassium plus chloride upon sodium plus chloride. This is our target equation. This is to be achieved. After deciding our target, my first step is sodium bichloride is given. From this we can have sodium bichloride plus 1 is equal to 1.5. This is the required portion in our target. Therefore, this is first formula I have made. Sodium bichloride is 0.5, thus we can say chloride is sodium by 0.5. Then I start with the equation potassium upon chloride, potassium upon sodium by 0.5, 0.5 divided by sodium upon potassium. This value is given to us as 0.7. Decimals can be cancelled out. Potassium upon chloride is 5 by 7. Add 1, again same to the first part, first step. Add 1 on both sides. We get 12 by 7. And 12 by 7 is potassium upon chloride. This is now second equation. If we divide second with 1, chloride is cancelled out. You are left with this ratio. And this will give you answer. Answer is 1.143. Here is fifth question. Question number 6. Sixth question is about a structure, pavokite. Sixth question. It is pavokite is a mineral with the formula CaTiO3, calcium titanate. This is pronounced as calcium titanate. So we are having CaTiO3, calcium titanate is there. Which of the positive ions in this crystal is more likely to be packed in octahedral holes? Here oxide is going to have CCP arrangement. Titanium is 4 positive. Calcium is 2 positive. Oxygen is -2. Overall charge is neutral. This cation titanium is going to accommodate in octahedral voids. It is accommodated in octahedral void, and calcium will go to your tetrahedral void. Not all the voids are occupied, only few voids are occupied in these cases. So we have titanium is going to octahedral and calcium is going to tetrahedral. Here titanium is present in octahedral, confirmed from its coordination number. Confirmed from its coordination number, because its coordination number is coming to be 6. Coordination number is 6. Coordination number 6, that means octahedral void is occupied by titanium 4 positive. In this question, 2 options are related to titanium. One is titanium 4 positive, another is titanium 2 positive. Titanium 2 positive cannot be the answer, because in that case crystal will not be neutral. If this is the formula, oxygen is -2, titanium +2, calcium +2, so not a neutral formula. This will be a wrong statement. Titanium 2 positive cannot be the option. The only option is titanium 4 positive. Next question, question number 7. Seventh question is about a void and its radius. In seventh question, there is a diagram shown to you as 3 spheres, central dot, and then again 3 spheres like this. Whenever a structure is made up of 6 balls and center position is taken by some other species, we can say this void is octahedral void. Octahedral void is occupied. Now A is the name of this species. This is called A. A is in octahedral void. It is written A+. This bigger ball is written as X-. Now radius of octahedral void, radius of octahedral void is 0.414 times of radius of X negative, that is anion. So we can say 0.414 times. Radius of anion is given 250 picometers. Multiplying these two, 250 into 0.414, it is 103.5. That is the answer in picometers, because edge length or radius is in picometers. In this question, arrangement is to be shown, and then there is a question regarding the A positive. A positive is an octahedral void, coordination number is 6, thus we can say radius of cation to that of anion, radius of octahedral void is 0.414 times anion. Your option is 103.5. Option A is the correct option. 7th question, option A. Question number 8. Question number 8 is from solutions chapter. Which of the following has been arranged in order of decreasing freezing point? First of all, you must know that freezing point is related to number of particles, and it is inversely proportional to number of particles. TF, that is freezing point, is inversely proportional to number of particles. Because freezing point is not a colligative property, it is inversely related to that of number of particles. You are given with KNO3 and it is 0.05 molar. First part, you are given with 0.04 molar calcium chloride CaCl2. Then 0.14 molar, it is given sugar. And fourth option we are having 0.075 molar of copper sulfate. N is to be calculated. How many particles are there? Here 0.05 into 2, because K1 positive, nitrate 1 negative, there are 2 ions in this KNO3. It becomes 0.1 molar, 0.1 mole ions. Now in calcium chloride there are 3 ions. Therefore we can say that 0.04 into 3, 0.12 mole ions are there. Then we have is 0.14 molar sugar. It's non-electrolyte. Non-electrolyte. When we say it is a non-electrolyte, that means 0.14 just into 1, it will remain 0.14. Last is copper sulfate. There are 2 ions. Multiply करके देखते हैं, it will become 0.075 into 2. This will become 0.15. It means number of moles are clear to us. Now we can arrange these in order of decreasing freezing point. Less is the number of particle, more is the freezing point. It means KNO3 should be at number 1. Then we have is 0.12, 0.1, 0.12, 0.14, 0.15. It means freezing point order is decreasing freezing point is going to be KNO3, calcium chloride, sugar and copper sulfate. Option valid is A option. Question number 8. Again the answer is A alpha. Now we have 9th question. 9th question is a compound X undergoes tetramerization in a given organic solvent. Van 't Hoff factor is. When it is tetramer formation means we are getting 4 units joined together to form 1. Tetramers means there are 4 units joined together to form a one single unit. This is a tetramer formed. In formation of tetramer, I is Van 't Hoff correction. 1 upon N is the topic. N is 2 for dimers. N is 3 for trimer. And N is 4 for tetramer. When we say N is 4 for tetramer, it becomes 1 by 4. 0.25 is the value of Van 't Hoff correction. So I becomes 0.25. Option is beta. 9th question. Option beta is there. 9th is beta. Now 10th question. Question number 10 is calculate the abelioscopic constant for water. Heat of vaporization is 40.685 kilojoule per mole. In question number 10, we want to calculate ableoscopic constant. Ableoscopic constant is Kb. When we say ableoscopic constant, Kb is to be calculated. Formula is m r Tb naught square divided by delta H vaporization into 1000. This is the formula of Kb. M is molecular mass of solvent. Molecular mass of solvent here is water and it is equal to 18. R is gas constant and its value is 8.314 joules per Kelvin per mole, but our answer is written in, value is given in kilojoules. It is 8.314 into 10 raised to power minus 3 kilojoule per Kelvin per mole. Now we have Tb naught. Tb naught is the boiling point of liquid, boiling point of water. Boiling point of water is 373 Kelvin, a constant. Delta H vaporization is given to you and its value is 40.685 kilojoule per mole. In this question, when we put the values 18, 8.314, 10 raised to power minus 3, 373 square divided by 40.685 into 1000. Kilojoules, kilojoule cancel. Temperature in Kelvin, and your answer after solving this is going to be 0.512. Units are Kelvin, right? Kilogram per mole. Mass is divided by 1000, it is in kilogram. Temperature is left because it is joule per Kelvin per mole. Kelvin per Kelvin, this is Kelvin square. 1 Kelvin is left with you. It is kilojoule per mole. Here it is kilojoule per mole. And we are getting the value for 1 mole. That's why it is Kelvin per kilogram per mole. 1 mole water is used. Question number 11. 11th question is, calculate the molecular weight of a substance if the freezing point of the solution containing 100 gram of benzene and 0.2 gram of the substance is 0.17 Kelvin below that of benzene. The cryoscopic constant of benzene is given 5.16 kg per mole. In the 10th question, your option is A alpha. Now 11th question we are going to solve. Question number 11. Calculate the molecular mass. It means MB you want to calculate. You are given with weight of benzene, that is solvent, 100 grams. Weight of solute, it is given as 0.2 grams. As it is in benzene, the I factor is taken as 1. Right? Now we have delta TF is given to you as 0.17 Kelvin. It's written as substance is showing 0.17 Kelvin below the freezing point of benzene. Below the freezing point means 0.17 times lower than that of freezing point. So we can say delta TF is given as 0.17. Cryoscopic constant Kf is given as 5.16. This is also given value.